Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at factorising quadratic binomials. I just want to take a second to remind you of what factorising is. Now, you would have done it before. You would have factorised expressions like this, 8x minus 12. So when we're factorising, we're doing the opposite of expanding. Expanding is where you start with brackets and you end up with something like this. Factorising, we want the brackets back. Factorising means you write the expression as something times something. So like if you factorise 36, you get 9 times 4. So the method you would have learned is highest common factor. You find the highest thing that goes into this term and also this term. So the highest number that goes into 8 and 12 is 4, and they have nothing else in common. So we put 4 out the front. And then in the brackets, we go 8x divide 4, or another way of saying that, what do I times by 4 to get 8x? And then what do I times by 4 to get negative 12? So if you expand this, you get this, because factorising and expanding undo each other just like multiplication and division. So if we were to factorise something like this, it's the same sort of process, but this time the highest common factor is 5y. So 5's the highest number that goes into 5 and 15, but both of these terms, this one and this one, also have a y in common. So we put that out the front. So what do I times by 5y to get 5xy? I need to times by x. What do I times by 5y to get negative 15yz? Well, I need to times by negative 3 to get negative 15, and I also need to times by z, so it's a yz. So this is factorising because I've written this expression as something times something. You know it's factorisation when you start off with no brackets, end up with brackets. So that's how we've been factorising before. Now we're going to apply this to quadratic binomials. So quadratic binomials are expressions that have two terms, and one of them's an x squared term. So all of these are quadratic binomials. All of them have an x squared term somewhere, and they only have two terms. So when you have quadratic binomials, when you have two terms, one of which is an x squared term, you have two different methods at your disposal. Firstly, you check if there is a common factor. If there is a common factor, use HCF, similar to what we did up here. If there's no common factor, try difference of two squares. So let's look at this one here, x squared minus 5x. So we've got two terms, one of them is an x squared term. So we're going to see if they have a common factor. So this term here and this term here have an x in common. So we put the highest common factor out the front. Now what do I times by x to get x squared? Well, that's just x. What do I times by x to get negative 5x? Just negative 5. Similarly, these two terms here have a common factor of x. X goes into itself once. X times 1 is x. X times negative 3x gives negative 3x squared. If you expand this, I get this, because factorising and expanding undo each other. All right, let's look at this expression here. Two terms, one of them's an x squared term. So we look for a common factor. So once again, they both have x in common, but they also have a common factor of 6, because 6 goes into 12 as well as 30. So the highest common factor here is actually 6x. So what do I times by 6x to get 12x squared? Well, it's just 2x. What do I times by 6x to get 30x? Well, that's just 5. Okay, so we're done. Once again, if I expand this, I get this. So that's all well and good for the highest common factor method, but what if you have to factorise something like this, x squared minus 4? See, these two terms do not have any common factors at all. So we need to try a different method. We tried difference of two squares. So difference of two squares is when you have a perfect square minus a perfect square. So in maths, difference means minus. X squared is a square, 4 is a perfect square because it's 2 squared, and we're minusing. So difference of two squares. That's a method you try when HCF doesn't work. So this is how you do difference of two squares. When you have perfect square minus perfect square, you set up two brackets, square root the first, square root the second, one bracket gets a plus, one gets a minus. 4x squared minus 9. These two terms have no common factor, but we have a perfect square minus a perfect square. So we'll use difference of two squares. So we set up two brackets, square root the first, square root the second. One gets a minus, one gets a plus. It obviously doesn't matter which bracket gets the minus, which gets a plus. It doesn't matter if it's minus then plus or plus then minus because you're timesing them. So if I were to expand this using FOIL, I get this. Similarly, if I expand this using FOIL, I get that. All right, so what about this one here? It looks a little different, but we're going to do it the same way. See, 4x squared and 81 have no common factors. The only factors of 4 are 1, 2, and 4. The only factors of 81, they're 1, 3, 9, 27, 81. The only common factor of 4 and 81 is 1, which doesn't help us. X is not common because this term does not have an x. So we have two terms, one of which is an x squared. So this is a quadratic binomial, but the two terms have no common factor, so we try difference of two squares. 4 and 81 are perfect squares. We have a perfect square minus our perfect square, so we use difference of two squares. And this is how you do difference of two squares. Set up two brackets, square root the first, so the square root of 4 is 2, square root of x squared is x. Square root 81, square root the second, one bracket gets a plus, one gets a minus. So for something like this, 2x squared minus 98, we can actually use both methods. See, 2 and 98 are not perfect squares, but they have a common factor of 2. So you always try highest common factor method first. So the highest common factor is 2. So 2 times x squared gives x squared, 2 times negative 49 gives negative 98. So now that we factored using highest common factor, this thing in the brackets is the difference of two squares because we have perfect square minus a perfect square. So we're going to factorize just what's in the brackets. We're going to leave the 2 alone. So to factorize using difference of two squares, we square root the first, we square root the second, one gets a plus, one gets a minus. So if you can't use highest common factor, you try difference of two squares, but it won't always work. If you have an expression like x squared plus 1, that actually cannot be factorized. These two terms have no common factor, so I can't use HCF. But this is not the difference of two squares, it's actually the sum of two squares. Difference means minus. So x squared plus 1 actually can't be factorized. So just because you can't use the highest common factor, it doesn't necessarily mean you can use difference of two squares. Try the highest common factor method. If you can't do that, try difference of two squares. If you can't use either, it either can't be factorized or you've made a mistake. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.